This is chapter 8-1, part 2, ratio and proportions. Please get your copy. All right, we began talking about ratios and the three ways you can write them, with a colon, with the word to, or as a fraction. But let me just give you a real life example of when ratios are really used. Okay, similar figures you hear often. Similar figures would be, for example, an architect or an engineer if they're designing a home. Okay, of course they can't build a real life-size model or something, so they make blueprints, a smaller version of that object or that home that they're going to build. So let's pretend that figure ABCD is the blueprint, and it's going to be expanded into a real life-size home that'll be 22 feet by something. Okay, well, again, as I stated, an engineer or an architect is not going to be able to come in here and make a 22 foot by something or another and then decide it doesn't work. They put it on a small piece of paper or a blueprint paper and they sketch it out. So they scale it downward and use smaller values, and then they multiply it by the same number for both sides, and I'll talk about that more, so that they can determine what it should actually look like in the end product. Okay, so here we have, as I gave them, for example, the architect would create a building. One of the first things they may do before building a large model is to create a smaller replica of it, which is this smaller figure ABCD. If this architect wants to build a home, he might build a smaller version. Here it is, using a proportional ratio, so that the house ABCD is just going to be a smaller version, the real life size EFGH. Okay? Now, the proportional ratio value for this small life size or paper model to the large one, the ratio is 1 to 11. How do I know it's 1 to 11? Well, I always compare the sides that are going to be similar. It's just like when we had triangles and I had two similar triangles, and let's suppose I had triangle A, B, C, and I was comparing the triangle D, E, F. Remember, we did corresponding sides where AC corresponds to DF and BC corresponds to EF, and then AB corresponds to DE. You do the same exact thing for whatever shape it is. In this case, it's a rectangular shape. So that means since AD corresponds to EH, and it does not mean they're the same length, it just means that it's a substitution. EH represents the smaller version AD. And because I know that they are supposed to be similar figures, because I'm told that, I can set up a proportional ratio. I can do the small over the large. Well, what is the value of the small? If I'm talking about the small, I'm talking about side AD, and it corresponds to what on the large? EH. And I write it in the same exact order because A corresponds to E, they're in the same spot. D corresponds to H. We talked about that before. And what's the length of AD? It's 2 over, what's EH, 11. Excuse me, 22. 2 over 22. And I'm going to write this in here so you can see a little better. And this fraction, or this ratio, I should say, can be simplified to 1 over 11. And we know that ratios can be written with as a fraction or with a colon. So it's the same thing as 1 to 11. And when I'm comparing, obviously I'm comparing the small to the large. I could rewrite that and revise that, and I could also write this as large over the small. If I did large over the small, that means that I would say segment EH corresponds to segment AD. And if I were doing that, pretend this equal continued there, that would be 11 over 1, which is 11. All right, in that particular case, I'm saying the large, I'm running out of room here, the large to small is 11 to 1. You have to be careful about the way they call it out. Did they say small or large to small? You got to give it in the order. that they call it out. So if they say small or large, then that means I must say 1 to 11. If someone says large to small, then I say 11 to 1. You must call it out and write it in the same exact order they ask you. So in this particular case, the proportional ratio is 1 to 11. We just simplify the fraction, or 11 to 1. But as I stated, you can only write it in the order that it's called out. So if someone asks a ratio for small house to large, we're going to say it's going to be 1 to 11. But if they ask what's the ratio of large to small, then it's going to be 11 to 1. Order does matter. You will get it wrong. Okay? Your engineer calling somebody else and they're asking for, okay, well, what's the ratio? They're calling on the phone. You say 11 to 1. When they ask for small to large, it should be 1 to 11. That person, when they're trying to get a contract with the company, if they're your partner, they're going to get it wrong because you gave them large to small and they needed small to large. So order does matter. Be exact. Okay? And when you know which order to go, because when I call this out, A, B, C, I know it corresponds to E, F, G, H. That means A corresponds to E, F corresponds to B, G corresponds to C, and H corresponds to D. So put it in the order that it corresponds. How do I know that? Here's an example from your book, page 485, number 3. Let's say I do know some proportional ratios. And let's say I have here the measure of angles in triangle JKL are an extended ratio of 1, 2, 3. What do I mean extended? Remember, ratios are at least comparing two things. In this particular case, I'm comparing 3 angles. I'm comparing this angle to that angle to that angle. Angle J to K to L. What are the measures of this triangle? Well, what does this say? This says that it's 1 to 2 to 3. What that means is simply is that angle L is going to be 3 times larger than angle J. So angle L is 3 times larger than angle J. And what does that also mean if I'm looking at angle J? That means that angle K, and I'll use a ring now, angle K is 2 times, and I'll put an X there, 2 times larger than angle J. Or if I said it the other way around, I could also say angle J is half the size of angle K. Alright, so let me come out with that. Hopefully you have it. Now, if I know that the ratio is 1 to 2 to 3, what does that mean? Well, first of all, if I'm thinking, you know if it's a triangle, you know that the interior angle must equal to 180 degrees. That means angle J plus angle K plus angle L must all 3 equal 180 degrees. And by triangle sum theorem, I can say that the measure of angle J plus the measure of angle K, which is 2x degrees, plus the measure of angle L, which is 3x degrees, is equal to 180 degrees. Combining like terms, x plus 2x plus 3x is 6x equals 180 degrees. Divide both sides by 6, x is equal to 30. So that means that angle J is 30 degrees because that's the value of x. Angle K is going to be 2 times 30 degrees, which is 60 degrees. And angle L is going to be 3 times 30 degrees, which is 90 degrees. Okay? Moving further here. Alright, proportion ratios. Proportions can be solved. I'm not talking about the way you write them now. We know the way we write them is with colons or 2 or as a fraction. But you can actually solve for a proportion if you don't know a value. For example, well, let's get started here. Let's look at first of all. If I have extreme values, if I have A over B is equal to C over D. These are my 2. Okay? B and C are going to be your extremes, and A and D will be your means, which we'll talk about. Make sure you know those, I'll say first. Now, to begin here, when I look at this information, I'm just going to let, I'll let this be 2 over 3 is equal to 4 over 6. So I'm letting A be 2, I'm letting B be 3, C be 4, and then our 6 be the D. So let's say this is 2/3 is equal to 4/6. You'll see what I'm talking about in just a minute, but just know that this is how a proportional ratio will be written. There's 3 ways to solve it. The first property, and know the property numbers, and the way to do it is cross product. Cross product is what you've probably been doing since 6th grade when you solve it algebraically. You should know that. The product of the extremes equals the product of the means. So that means the extremes times the means will be equal. So the extremes and the means. So extreme is B times C is equal to A times D. When I multiply the extremes, B times C is going to be equal to A times D. So here it is right here. If A over B is equal to C over D, if I'm taking the extremes times the product, that means A times D is going to be equal to B times C, which is here. And remember I said that I was writing that as A is 2, B is 3 equals 4 over 6. And remember, I'm doing the extremes times the means. So here I am. I'm going to do my means. And let me do them in the same color here. My means are blue. So 2 times 6. Doing my means times my extreme, which is 4 times 3. What does that look like? If I multiply the cross product, that's going to be 2 times 6. And we're saying that it's equal to... We're saying that it's equal to 3 times 4, and they are. Both are equal to 12. That's showing you that the means times extreme will be equal, or the cross product. We call this the cross product when I cross multiply. You learn that again. So the cross product 2 times 6 is equal to 4 times 3. 12 is equal to 12. I just showed you that if I put in numbers. The second way is by reciprocal. How do we solve by reciprocal? Reciprocal is property number 2. That's just, again, reciprocal, we learned it as flip it. Okay? So if my original equation says A over B is equal to C over D, then that just means if I flip it, now it's going to be B over A is equal to D over C. So remember, what was my original? I said my original equation would be 2 over 3 is equal to 4 over 6. A over B equals C over D. The reciprocal means the flip it will be equal. Well, now that means I should be doing 3 over 2 equals 6 over 4. And again, if I cross multiply, they're still the same. 3 times 4 is 12, and 6 times 2 is 12. So I can still use the cross product. They're going to be equal if the reciprocals, if I take the reciprocal of both, they will still be equal. I can't just take the reciprocal of the first, the A and B, and not do the C and D. I have to do both. And then finally, it's property number 3. Property 3 just says A over B is equal to C over D. Then that means if they are truly ratios, then that means that I can say A over C is going to be equal to B over D. What does that look like? I have A over B is going to be 2 over 3 equals 4 over 6. Then that means now I'm going to say that A is 2 over, my C is 4 equals 3 over the 6. And if I check it, you can just do the cross product. Then 4 and 3 make 12. 2 and 6 make the 12 as well. So they're still equal. If they are truly proportional, that simply means that if I have A over B, it's going to be equal to C over D. Then I can still do also A over C, and it's going to be equal to B over D. Let's check really quickly. And actually, I'll hit pause. I'll do a part 3 for you.